software-defined access is a little insane in a good way. So insane, and I love it so much that I felt like I had to talk about it. It's really not in detail on the current CCNA. You will look at it in the CCNP Encore, but I felt like I just had to tell you about it, just to give you a little taste of what it is, because it's so stinking cool, and it plays into what DNA Center, the digital network architecture, the controller that Cisco gives us, it plays into how that works. And it so fundamentally changes the way we design our networks. Similar to ACI, what we just talked about, it's basically ACI for the campus. Oh, okay, let's talk about it. So what Cisco ACI did for our data center and how it automates everything, DNA Center and SD Access does the same thing for our campus environment. So DNA Center is here to stay. Stay right there, bud. He's going to be doing all the work. Most of what he's going to handle is going to be the overlay. If you recall, for software-defined architectures, we got the overlay, and then underneath that, we've got the underlay. The underlay being the physical connections of all of our routers and switches and wireless and whatever devices you have. Let's focus on that first. Now, I do want to say that when you're doing a new install, we're talking greenfield, meaning you are just, I want to go all Cisco in. I'm going all in with it, Cisco. And you buy all new Cisco equipment, top of the line. Greenfield deployments, the DNA Center controller will handle the configuration of your underlay. It's intense, it's crazy, it's cool, it's awesome. And for our time talking about it, and for the example, let's assume that is the case. Greenfield DNA Center comes in, blows it up, it's amazing. Now, I wanted to bring this up. I wanted to talk about this because, again, it's insane. Let's look at the first few things that happens here. First, let's cable some things up. All right, nice and cabled up. Kind of looks familiar, right? Kind of looks like a spine leaf architecture that we just talked about. I told you it was used commonly. Doesn't have to be used, and you might see something very different from this, but not a big deal if you do. Now, this will be our underlay network, laying the foundation for our overlay so we can use all the cool things like VXLAN and ooh, so fun. So the job of the underlay is just to be connected. And so we'll assign our IP addresses. We might have an IP address space of 10.1.1.0/24. And that's the IP address space of our underlay, which will be different from the overlay. Now again, what we're doing here at DNA Center, if you have a greenfield, just does it for you, but we're kind of walking through the steps here. So let's assume they all got their IP addresses, and then we set up the routing protocol. Remember, it can be really any routing protocol, but with DNA Center, if it sets it up, and really if you set it up yourself, they advise to use ISIS. Why? Well, that's out of the scope of the CCNA. It's just really great for this situation. Now, because there are no layer 2 links, it's all layer 3, and there's no spanning tree, there's no ether channels, none of that stuff. Because it's that way, we call that a routed access layer design, because every link is routed. Now that is the underlay. We're done, or DNA Center's done. So now it's time for the overlay. In DNA Center speak, the fabric is the overlay. And this is where things get really, really fun. So we have our underlay taken care of. And you're probably wondering, what is this weirdo over here standing off to the edge? We'll talk about him. But here we go. Buckle your seatbelts. This is... And it's going to be brief, and it's going to be high level. If you want to go deep, there's the CCNP Encore, which is going to cover a lot of this. And then they may, I think, eventually will have a specialization, a concentration to go over SD access. There are 3 planes of operation. I know you thought we were done talking about planes, but here we are again. 3 planes of operation when talking about the SD access fabric. Now, when thinking about a router or a switch and the three planes, get that out of your mind. This is different. This is about SD access and how SD access itself divvies up its roles. As far as the control plane goes for SD access, it uses a technology called LISP, L-I-S-P. It's an IETF standard, RFC 6830. It's an acronym. It stands for Location Identity Separation Protocol, which sounds like a some kind of issue you might have, but it's really cool. Now, LISP is crazy. I keep using the words crazy and insane because it's all up in this. But it's like DNS for your network. So whereas traditional networks, you have layer 2 functions so you can know where a host is with a MAC and a layer 2 MAC address table, right? And then with routing, you have layer 3, so you got OSPF or EIGRP, keeping track of where things are and how to get to places. Scratch that, erase it. LISP does something different. It identifies each host, each whatever device that connects to our switches with an EID, an endpoint identifier. And it matches that EID or the endpoint ID to something called an RLOC, a routing locator. So for example, my phone, if it were on this network, would have an endpoint identifier, and then the routing locator would be how do you reach my phone? What device does this phone live on? Is it connected to which of these switches? That's the routing locator. Now, how these two things map are actually included in a master map. We'll touch on that here in a second. Just know that the EID to routing locator stuff is mapped together in a map. Where is that map? We'll talk more about it here in a moment, but it's similar to, very, very similar to DNS. If you want to know how to get to CBT Nuggets, you'll query a DNS server, cbtnuggets.com. Where is it at? And it'll reply with an IP address. Same situation here. Hey, where's Chuck's iPhone? It's on this switch. Similar situation. But to tell you where that map lives, let's talk about the type of switches we have in our fabric here. First, these guys right here, where our devices connect, our endpoints, are called fabric, if I can spell fabric, fabric edge nodes, because they are on the edge, living on the edge. So let's say, for example, we've got Bob on the network, just assuming that every one of my people here have a laptop we're connecting to. We got Bob, we got Susie, we got Rob, and of course, we cannot forget about Beatrice. So endpoints connected to fabric edge nodes. Now in the SDA fabric, these fabric edge nodes have a very, very important job. They have to keep track of who's connected to them, and they use traditional means for that. Hey, Bob, dude, what's your MAC? Dude, yeah, it switches. That's the new certain terminology. They say, dude, dude, what's your IP address? Dude, what's your MAC address? And they register that with the map. Where's the map? The map is right here. This is our other type of SDA node in our fabric. This is a fabric control node, often referred to as a control plane node. This guy, he's the map. I'm the map. I'm the map. I'm the map. I'm not going to keep going. He's the map. In most environments, he's going to want to be a pretty big, beefy server, so I'm going to make him just a tiny bit bigger. There we go. He's going to have some resources to have that mapping depending on how large your campus fabric is. Also, how many hosts you're going to have connected, because he has to keep a mapping for every host connected on your network. Of course, that begs the question, how does he know about the host? Well, the fabric edge nodes let him know. They register whoever's connected with them to the map. Bob's over here. Susie's over here. Rob's over here. Here's Beatrice. So he has that address book. He's like the Yellow Pages, DNS. Now, why is this revolutionary? Why is this cool? Chuck, why are you telling us about this? Well, because of a few reasons. First, let me find some room here. Smaller routing tables. This design, oh, my G is a little slack there. This design is very simple, and keeping track of where the nodes are, pretty simplistic. I mean, if it gets large, you'll need a larger fabric control node, but it's pretty simple to identify where things are. Another key benefit here, and it's so cool, is device mobility. Device mobility? How? We'll get to that in a moment. Put a pin in that. Let's move on our control plane list here. So Lisp, it's basically replacing some routing protocols, and it's got a smaller routing table. We can more easily identify where things are. Just think of it as the DNS for our network. Next on our list of the 3 planes is the data plane. We've kind of already talked about this when we talked about SDN architectures, and that is VXLAN, Virtual Extensible LAN. VXLAN allows us to encapsulate layer 2 Ethernet frames inside layer 3 UDP packets. Let me repeat that. VXLAN allows us to do layer 2 over layer 3. Right? So we're creating virtualized layer 2 subnets, and it's crazy. That's why we have the underlay. It's just to have the IP layer 3 connectivity. VXLAN on top of that just makes whatever you want to happen. A simplistic view of this is if Beatrice right here wanted to talk to Bob, well, she would first go to her fabric edge node, and the fabric edge node would find out, hey, where's Bob, by asking the map. Once it has the map, it creates a tunnel. Tunnel o' love, the VXLAN tunnel, straight to the fabric edge node. At least from the perspective of the overlay. From the underlay perspective, it's going to be like a hop. But tunnel o' love, that's a direct connection. Of course, there's a lot more to that under the hood. That's the basics. And then our third plane, we have what's called the policy plane. And I don't have to move it down here because I'm out of room, which is called CTS, or Cisco Trust Sec. This is really cool for a lot of reasons, but I want to show you just a few powerful reasons right now. So when we set up like access control lists, ACLs, we normally have to say you can allow this subnet or you can allow this list of IP addresses. It's all IP address based. Same kind of situation when we set up QoS and such. It's all based on the IP address. But with Cisco Trust Sec, we don't do it that way. They use something called SGTs, or Scalable Group Tags. SGT. And they assign these tags to groups of endpoints, or authenticated groups of users and endpoints. And it's based on that information we can apply policy. We don't look at MAC address or IPv4 address, IPv6 address. It's all about the tags applied to these endpoints. Think of this as like a security group. Basically a group of devices that has shared access to things. So we might say Bob and, do a better circle than that. Bob and Susie are part of the, this is the color reference here, the accounting group. And Rob and Beatrice are part of the marketing. Let's say we don't want accounting to even talk to marketing. They got in a fight, we cut off communications, no more network access to marketing. Traditionally, with an access list, you would block the accounting subnet from accessing the marketing subnet, but not with TrustSec. We're just going to say, I don't want marketing to access accounting. That's it. We do that in the DNA Center portal. We say, hey, DNA Center, I don't want these two departments talking. Make it happen. So let's go through a flow real quick of how it looks. So when Beatrice connects up to the Fabric Edge node, her first little switch, her access switch she's connected to, first thing that happens is she's authenticated. And this could be a username, password, it could be a token on her computer, whatever. So the Fabric Edge node will talk to DNA Center saying, hey, I've got this Beatrice lady here. Is this really Beatrice? Okay, it is, cool. Does Beatrice have any like security group she's a part of? And DNA Center goes, in fact, she's got these scalable group tags right here. She's part of the marketing group. Here's all that information. So now that the Fabric Edge node has identified Beatrice and knows what security group she's a part of, now if Beatrice were allowed to talk to Susie, Beatrice's Fabric Edge node would go, hey, the map, where's Susie at? Where's Susie? And the Fabric Control node goes, oh, Susie's over there at that one, this one here. So she would create a love tunnel, a VXLAN tunnel, tunnel o love, straight from the Fabric Edge node that Beatrice is connected to Susie's Fabric Edge node. But, that's not the case, though. Beatrice cannot connect to Susie because of their security groups, and because we told DNA Center we don't want them talking, so it just doesn't happen. The Fabric Edge node already has that security group association, talked to DNA Center about it, and says, can't let that happen, Beatrice, I'm sorry. Now, I want to bring all this home of why this is cool with the number 2 reason I was talking about, device mobility. Here's what can happen. All that magic can happen no matter where Beatrice goes. So if Beatrice decides to pick up and move to a different location, let me get myself out of the way here so we have more room. And let's say Beatrice moved to an entirely new building, Building 10. And from the underlay perspective, these 2 buildings are connected via a routed link. It's a big routed link. And as far as IP addressing, well, the underlay, I'll just put UL over here, again, could be 10.1.1.0/24. And then over here, the underlay could be 10.2.1.0/24. So different networks, they have routed links, all routing on the underlay via ISIS. And then we didn't talk about what the overlay IP addressing scheme might be. So let's say the overlay IP addressing scheme might be 172.19.2.0/24. So that'll be the IP address scheme for Rob, Susie, and Bob over here. But guess what? Over here at this other building, it'll be the same too. So when Beatrice was over here, let's say she had the IP address of 172.19.2.101. Well, when she moves over here to building 10, guess what? She keeps that IP address. No matter where she goes in this fabric, in this network, whether it's in the same building or a whole different building or wherever it is, she can go anywhere else, have that same IP address, and when she connects up to this Fabric Edge node right here, the same process happens. The Fabric Edge node goes up to DNA Center and says, hey, I've got this Beatrice person. Is she who she says she is? Is she authenticated? And the DNA Center's like, yeah, she is. Here's her security group tags. Internet outage. I just took out her pipe. Put you back in there. And then the Fabric Edge node will communicate with the map and say, hey, map, I got Beatrice over here. She's with me now. Same IP address, which is commonly what we'll use as our endpoint identifier with the Lisp functions. She's just in a different location now. And she'll be part of that same security group. So the beautiful part of this is that normally we'd have to worry about moving someone and then readjusting our access list and thinking about how they route to this and that. No. With this system, no matter where they go, everything stays the same and stays consistent. And notice, you're probably thinking like, well, if this is a routed link, how does it work with them being basically in the same subnet on the overlay? Well, that's the magic of VXLAN. Even though this right here is a routed link on the underlay, from the overlay perspective, it doesn't matter. If Beatrice wants to communicate with Rob, Lisp tells her switch where he is, and then VXLAN routes layer 2 over layer 3 via the VXLAN tunnel, and it's like they're right next to each other. It's magic. Whew, that was a lot, and I wish I could spend a lot more time here talking about all the amazing features, because I barely scratched that surface. There's so many things DNA Center can do with SD Access, man. But again, I wanted to give you just a taste of what it looks like. We talked about the underlay, the routed access layer. Everything's layer 3, everything's routed. Most of the time with DNA Center is going to be ISIS, and then the overlay is whatever you dream it to be. Layer 2 over layer 3 with VXLAN and the tunneling. It encapsulates and de-encapsulates the frames over the tunnel. It's pure magic. And with SD Access and the overlay routing protocols, what? No, we use Lisp. we have a map of where each device lives, each device is connected to. A simple routing solution. And mobility galore. It doesn't matter where they go, we know who they are, we know what they have access to. It's just cool. I hope this has been informative for you, and I'd like to thank you for viewing.